Okay. Um, Now this is just essentially a continuation of a talk I gave at the last IOTA meeting, a year down under, at the meeting in mid-October 2015. At that time, we had interrupted our 11-month stay in Australia to come home to visit my dying close colleague of many years, Robert Farquhar. Unfortunately, he passed away right during the last day of the IOTA meeting. And But anyway, then we returned to Australia, and this describes our experiences then after we resumed our stay there on October 29th last year. So next. This just to recap that we started our trip to attend these annual astronomy conventions that they hold, and they ping-pong them between New Zealand and Australia. So we started our trip not to Australia but to New Zealand to go to the RASN annual meeting and the 9th Trans-Tasman Symposium on Occultations. Their meetings are about as large as ours. They have a very active group, so even though they have a lot less population, they've done quite well. But then our stay in Australia ended with the next year's meeting, which is with the National Australian Convention of Amateur Astronomers. That's the NACAA. That was held in Sydney, and they always hold it on Easter weekend because that's the only weekend when all of the states of Australia agree to have both Friday, Passover, and Easter Monday as state holidays. And so they have a 4-day weekend that they can fit this into. And so the 10th Trans-Tasman Symposium was held at starting on the last day of NACAA. They also had the TTSOO 10. So next slide. So I'm going to talk about this event. I talked about it last time as our most successful observation that we've ever done, actually, where we ran 11 stations along the Stewart Highway, and only one of them failed, so we ended up getting 7 positive chords in our deployment, including at our attended station at the northernmost chord. So this is one case where the star catalog comparison indicated it might be better to cover north, but we covered a little bit south to hedge our bets. But we had our last station to the north was north of the 1 sigma limit, and we did have a short occultation there. Anyway, the next slide. This just shows the profile that we got from the eclipse, and you can see that the chords don't fit an ellipse perfectly well. This is as best a fit that you can make to the chords, but it looks like there might be some topography or something that's causing these chords. But as I will show, though, that it's not just that, it's also partly timing errors, which I'll discuss more, because it shows that there are nonlinear drifts can be a problem with the Canon ZR camcorder clocks, and so we ran some tests to quantify those. And I'll talk about those later in the talk. I did those tests in January and February. Anyway, this just shows what it was, and as of without any corrections. Next slide. And I wish Paul Maley were here because I want to stress this to him. Then just before the IOTA meeting, our last days in Australia before we did the emergency trip back, it was this October 8th occultation of Venus by the 15% Sun crescent moon. And I have a whole presentation about that, so I won't say anything more about it here. Next slide. I did mention it last time I showed, I think we showed the video at the last slide. Anyway, when we returned to Alice Springs, though, when we returned to Australia, we went to Alice Springs. That's where all our stuff was, still in a storage container. compartment because we left our apartment that we had rented there. There's no point in continuing the lease at that point, and so we had to go back and get our things. So we decided to spend a week there to explore around Alice Springs the things that we hadn't had a chance to see during the 4 previous months. So one of the main things we wanted to see was Goss's Bluff, which is this huge impact structure, very spectacular. This shows a view of the inside of the crater. They actually think this is just the central peak of a eroded central peak of even a much larger crater. And we also explored the McDonald Ranges, the spectacular east-west mountain range that goes east and west from Alice Springs. Next slide. Then in about the beginning of early November, we drove from Alice Springs to Canberra and decided it was really getting hot as the summer started in Alice Springs and starting to become unpleasant and a little bit cloudier too. So we decided to move. We wanted to be near Dave Harold. We're good friends with him, and so first we looked to see if there were any motels in Yass or places we could stay. We stayed just a couple of days there, but there wasn't anything really very good. And so we ended up going to Canberra, which is, of course, a much larger city, and staying in the northern suburbs there. But this shows we saw some interesting things on the way there, including the spaceship from the movie Pitch Black, which is permanently parked in Coober Pedy, northern South Australia. That's also a lot of the big opal fields there, and the countryside is sort of ruined with all these pits. It's sort of spectacular in their own right, but it's also one of the hottest areas of Australia. The temperature's gotten as hot as 53 degrees Celsius, which is somewhere, it's, Canberra was surprisingly cooler. I mean, we were going there for that purpose, and although the place we rented there, and it was in the summertime, was not air conditioning, we really didn't need it. There were a couple of days when the temperature got into the high 90s, but it cooled off at night well enough. This just shows we climbed the highest mountain in Australia with Dave Harold, and that's us at the top of Mount Kosciuszko. There are a number of other mountains that are almost as high around it, but this is the high point about 7,000 feet above sea level. So it's one of the few places that an average person can easily get to, the highest point on the continent. Next slide. We did a couple of good asteroid occultations while we were there. We traveled northwest of Dubbo soon after we arrived there. This was on November 15th, and we arrived like on the 6th or 5th or so of November. So anyway, we had this was this was just mentioning, this is the asteroid Lampetia, and we got 3 positive chords on it, pretty nicely scheduled. The event occurred in the late evening, so we had enough time to deploy 4 stations. We're trying to deploy 4 stations. We actually left something back at our motel, and we lost an hour going back and retrieving some critical items. It was just a stupid mistake, but anyway, Joan and I then did this deployment. It's about 400 kilometers north of our home. It's in northwestern New South Wales, but it's inland a couple of 100 kilometers, in farm country mainly there. Sort of like here, like Oklahoma, is very much reminiscent. But this asteroid was of special interest to me because on before the Asteropy event, I had one of my best deployments was on August 24th, 2014, when we went to central Missouri, stayed at Jones Brothers' place, and we ran 6 stations then, and I had 5 positives and 1 negative for that event. So Didn't do quite as well as that here, but we got a credible result. Next slide. And then in mid-December, a month later, we went back to that area, but farther north. And almost, we actually got within a couple of kilometers or so of the border with Queensland. You know, during that time, we spent a few days just sightseeing too, and we saw the Anglo-Australian Observatory, which is near there. And from the Anglo-Australian Observatory, they have a solar system model spreads out, and they have the Pluto and Dubbo, and but other things near Coonabarabran and so forth. And the Warrumbungle National Park, a very scenic area, is essentially surrounding the Anglo-Australian Telescope Observatory there. Um, and But our real purpose was to observe this occultation of a star by asteroid 579 Cydonia, and we deployed 5 stations. We had a failure. We were at a 6th station we tried, but we got 5 stations, and 2 of them got hits and 3 of them had misses. This is around the town of Moree, but this was the one collaboration we were actually able to do with John Broughton, and he deployed 3 stations, and he had 1 failure, but two hits. So together with the 4 of us, 4 stations that we got a decent solution. Next slide. We took a week in the beginning of January to go down. We actually left, we arrived in the area on New Year's Eve, and when my brother flew into Hobart, and so we had New Year's down there. And this just shows some of the interesting places we saw in Tasmania. We had pretty good weather there, and this shows us all at a cafe with my brother here and his wife Helena. And so next slide. I mentioned this graze of February 4th, which is the most distant graze from our home in Greenbelt we've ever done in Bridgeton in the extreme southwestern Western Australia. A 7.6 magnitude star, 16% sunlit moon, but a small cusp angle. So these things work much better with the small scopes when you have bigger cusp angles, but you get what you get. And the altitude was 28 degrees, was fine. Next slide, and I have south up here because we're in the southern hemisphere. It just looks better with the way things look. Now this just shows the graze path on 3 different maps showing how it just cut across the southwest corner of the state. We flew from Canberra to Perth and then spent a week in sightseeing and observing this graze and another event which I'll talk next. This shows the area around Bridgeton here. This is Bridgeton where we stayed, and this shows where the path, multiple event zone, crossed the road going northwest from there. And this is a zoom in on there's a best zone, and we set up our 2 attended stations here. Next slide. This shows the predicted profile of what we were trying to do. We were trying to hit this area for the best zone, but there were other areas that had good profiles too, or good multiple event zones. So we tried to run 4 stations here. Our equipment was set up to observe an asteroid occultation, which isn't so difficult because you don't have the moon in view, and so we could use the MIDI telescopes. We brought 1 maxi. We had 3 MIDIs and 1 maxi. We had a couple more MIDIs, but for the grays we just ran these scopes because wasn't sure if the MIDIs were up to the job. Turned out the maxi successfully recorded a few occultations of the star. I had a reasonably good show of it, and that worked. But the star was really too faint for useful data with the MIDIs. And you can kind of see the star sometimes in the MIDI views, but you really have to squint, and it's not. The signal to noise isn't good enough to do much with it. And you're right next to the cusp. That was the other problem. So next slide. You'll see that a bit in the Aldebaran recordings that we did, that the cusp is right there, but the star is so bright. very easy to see the events. This was, you know, we traveled east of North and West Australia for this Desiderata asteroid occultation. The path was more a north-south path, so we were set up on this east-west highway, the one that went to Kalgoorlie that I had driven back in 2009. But this time we did the deployment. We also observed some interesting national parks in this wave rock formation, it's called, in near Haydn. That's you can see the trees there. The wave, it's about you know, 50 feet high or so up to the crest from the ground. Um, and Anyway, this shows the profile of the asteroid. It doesn't show up very well in this view, but we ran 6 stations, um, and um, um, and I forget what this one was. I think there was one other observer. Yeah, there's one other observer who tried the grays farther west of us, and he had a miss. But all 6 stations that we ran were in the shadow, and unfortunately, the 2 ones in the middle we had problems with the timed recording things, and we've figured out a way to get around that now. And so it was sort of stupid. We should have. Instead of using those bags like we did with the reflective thing. That also would have saved us from the dingo last year if we'd known to just, all you do is you know, put them in the bag, but without the damn the plastic bar to try to reflect the infrared. You just put the camera next to the you know, programmable remote thing, it'll see it, you know. And that's the simple solution, was the best, rather than what Scotty had recommended. But anyway, we did get 4 nice chords, including 2 short chords. We were just lucky that the path was right where we observed. Well, it wasn't lucky. It was Steve Preston's great predictions. Next slide. And also the asteroid was a little bit elongated in direction perpendicular to the path. But anyway, I was always wondering about, and I really figured out that no one, I thought that Scotty had done some tests or something, but no one had really done some good tests of the temperature dependence, you know, of things that, you know, Steve Preston has complained a lot about our using, depending upon the camcorder clock for, you know, we get recordings before and after with the Kiwi to get some accurate calibration of the camcorder clock, and that's fine. You can then get the times and everything, but how accurate is it really? And so I did some tests based upon the asteropy occultation and on this Desiderata one, which we just did, and essentially tried to duplicate the environment and everything, the conditions. So I did it at the same times relative to the time of sunrise, because that was sort of the key thing. And when we did the asteropy event, the temperature was around 15 degrees Celsius it got down to, or 14, somewhere around there. So it was in September, so it was the equinox, and in the northern desert there, it was it didn't get you know, real cold or anything, and it was rather benign environment and everything, but we want to try to duplicate those temperatures. So one of the tests I did we had about the same temperature then when later on in February in the summertime and at the higher elevations in Canberra. So we ran one test there, but the other 2 tests were done in, we were near Brisbane at the time of the Gold Coast, and it was quite a bit warmer. Temperatures were around 22 degrees Celsius at night or so, and so what I did is put the cameras in the refrigerator for a few minutes, for half an hour or so, to sort of simulate the colder conditions on the average that they would have. But the 3 tests all gave pretty similar results. You can see what I did is ran them, then each of these cameras, you know, getting time-inserted data with the IOTA VTI, both at the pre-calibration time and the post-calibration times that we'd actually use during the occultations, and then also get it at the time of the event. with a recording with the VTI. So we could see, we did a solution. Brad Timerson helped out that. He did the solution based upon the pre and post calibration times and what the camcorder clock said. Okay, we have the time of an event there, and so using the camcorder clock, Brad told us what time the event, an event occurred at, and then we also knew that, but we knew the exact time of the event because we had the IOTA VTI recording too, which we didn't have at the events. So we had, we had, these are the station numbers. We had 5 stations. The northernmost one and the southernmost one were IOTA VTI time inserted, but the middle ones weren't. And that was sort of, we had 2 stations for Desiderata and 2 which were time inserted and 2 which weren't. So anyway, this shows the time in hours before the pre-point hours before and after the event that we did how long it took us. So the total length of time is the sum of the absolute value of these, the total time between the calibrations. We had, as we said, we had 3 tests. We didn't do the Desiderata ones until the second time. And then and these are then the average differences in those timings, and some of them are pretty small, but most of them are of the order of 3 4/10 of a second. So that's the error that we were getting. So if you don't do any corrections for your times, that's the sort of error that you're actually getting. Brad does these solutions and says, okay, you have 3/10 or 4/10 of an second accuracy, and that's what we've been putting in all our reports. But I say we should really use about 3 or 4/10 of a second, and that's if you do it right, where you do the calibrations as soon as possible when you set up and again when you leave. If you do the calibration earlier, you should fudge these numbers a little bit larger. If you do the calibration, the pre-calibration, sometimes you do it in the afternoon before you leave even. We were doing that for a long time. So anyway, we got some hard information finally on these sizes, and the question is how consistent they are between the 3 different tests. And so we could get an error in these estimates is sort of given here, and it's of the order of 2 or 3/10 of a second. So if you can, they were pretty consistent, the clock drifts. So if you apply a correction, in theory you should get the accuracy almost to the accuracy of what you, the Rodi and so forth can determine from your event times. So this all gives that. So deviations from a constant rate were similar, and so the times were improved by applying an average of the test corrections, and it resulted in smaller residuals for the fit, as shown in the next slide. But without tests like these, as I say, there's errors of a few tenths of a second are likely in the past occultations where we didn't do this, and it's encouraged me to get more time inserters. And there's 5 of them over there. People should buy them. Maybe we'll buy. We bought 3 before coming here. We might buy another 1 or 2.
I'm confused. How can errors creep in if you record the VTI time when you set up your unit and when you record it when you pick it up? Is it possible? Is it that the clock doesn't drift linearly during that?
That's exactly it. Yeah. Ted was asking why why there are any errors, and because we've been assuming all along that the clock drift is linear, meaning we take the linear part out by doing the pre and post calibrations. But there are also second order terms, in that drift. There are drifts away from the linear rate, and that's what we were trying to find, which we did. And because it depends upon a crystal that is temperature sensitive, and so there can be depending upon differences in the temperature of the crystal in the camcorder, which as the camcorder heats up as it's running and different things.
The source of heat must be the camcorder itself.
Yeah, yeah, yeah.
You're just talking about the drift of the clock display itself, correct?
Yes, yes.
Is there any drift in the frame rate?
I don't know. Yeah, we didn't run. Of course, well, no, the frame rate is. Yeah, 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 they do. Even the clock, the camcorder clock, is embedded with the time, so we know the time. It actually does it just every second, so you have to count between seconds. But it's pretty consistent. There isn't any big drift we found. We never found like there's 32 or or things like that. Yeah, yeah. Yeah. So there's a question about um, the rate of the clock of the camcorder, frame rate, but the frame rate doesn't change significantly because of
Reheating the cameras by running them in idle mode for a while. That could probably help. Well, not the cameras. It's really here. You're like, well, yeah, you're really about the recording device in this case. Right, the recording device, whatever it is.
Yeah.
Whether it's camera or
The problem is you're leaving these things out for hours, and you don't want to use up the battery for something like that. Yeah,
batteries, preheat batteries.
yeah, yeah, you could, yeah, yeah, maybe in cold weather areas or something. And these weren't particularly cold weather events though, so, but in cold weather, I always protect the equipment with hand warmers, and, you know, so otherwise they die. So um, anyway, and if errors of greater than 1 second can occur if the calibrations are done like half a day or more from the event, which we did some of that sometimes in the past. So, but we decided, especially once Steve started complaining about it, we made sure to do the recordings before and after um, the event as soon as possible. So let's wrap up. There's just a couple more slides, I think. Okay, this shows the stereopy profile with the corrections applied, and you can see some of that rattiness has decreased, and the residuals have, the goodness of the fit has improved, such that the residuals are were about 30% smaller than they were before. So it wasn't, so I think there's still some topography here showing on the Astra. You don't expect it to be a nice ellipse exactly like that. There was no shape model for that. And Dave Harold, though, made a remark when I showed this at the TTSOO meeting. He says, but have you seen the shape model? And he mentioned there is a shape model now, and he said, I think I actually found the fit was better with the shape model before you applied the corrections. But, but that's hard for me to believe. I think they're. Okay, Steve, Ted, be sure to send me Dave's file on future grazes. It has a shape model 2, in fact. Okay, okay. So that was, yeah, I'd be interested in seeing I haven't seen the shape model fitted to this. If Brad has the observations, if he could do that, that would be interesting. Okay. Well, let's go on to the next slide. Anyway, it's just saying how we attended the 50th NACAA meeting. It was their 50th anniversary on TTSOO 10, and then and we spent the last couple of weeks in the Sydney area. I came down with some sickness from our trip to Indonesia for the eclipse, which I'll mention in early March 9th. But we did get some sightseeing of the Blue Mountains and of Sydney itself. And we returned in time for the April 5th occultation by Cleopatra. It's a separate story. So we're back home now. That's it. Thank you.